The Hobart nested stellar unit architecture, macrovascular capillary geometry, dodecahelix bone rings, and decentralized kinematic mirror reflexes in type 2 to 5 cosmic organisms. 1. Abstract. The structural stability of civilizational infrastructure operating across Kardashev type 2 through type 5 scales is fundamentally constrained by material shear, thermal dissipation limits, and latency in centralized command networks. Traditional static engineering models fail when scaled to stellar and galactic dimensions, succumbing to gravitational collapse or resource starvation. This paper formalizes the Hobart nested stellar unit architecture, a fully modular, biomimetic megastructure framework. By utilizing a single, mile-diameter universal dodecahedral unit as a fundamental cellular block, the architecture constructs macro-scale, mega-units that organize into self-correcting, living cosmic organisms. Equipped with internal fluidic capillary networks, omnidirectional fusion propulsion, 50% energy storage capacity, and decentralized kinematic reflexes, this architecture ensures that the macroorganism maintains continuous metabolic homeostasis without starving, overheating, or collapsing under its own gravity. 2. Theoretical foundations of the 1-mile universal unit. The foundational element of the Hobart architecture is the universal dodecahedral unit, standardized at exactly 1 mile in diameter. The 12-sided regular polyhedral geometry provides optimal spatial packing density and multi-axis structural redundancy. 50% of the internal volume of every unit is dedicated to ultra-dense energy storage cells, providing an immense, decentralized power reserve across the entire collective mass. The remaining volume houses processing nodes, matter storage reservoirs, and superconducting field generators. Each unit is equipped with omnidirectional fusion jets along its perimeter for precise spatial maneuvering, an internal high-mass flywheel for kinetic stabilization and rotational momentum management, and deployable, retractable solar mirror sheets used to focus, redirect, or shield high-intensity stellar radiation as operational requirements dictate. 3. The principles of hierarchical nested morphology. To transcend the physical limits of single-block manufacturing, the architecture employs a recursive, fractal nesting protocol. Individual 1-mile units do not merely link together in flat, two-dimensional grids. They aggregate to form star-sized, mega-units that mirror the exact dodecahedral geometry of their constituent blocks. A primary mega-unit is composed of millions of tightly bound standard units, functioning as a single, macro-scale structural cell. This nested hierarchy allows the system to operate across vast dimensional tiers. Microscopic material transfers at the individual unit level aggregate smoothly into star-scale mechanical actions, giving a galaxy-spanning structure the flexibility and cohesion of a single biological entity. 4. Macrovascular capillary geometry. Resource distribution within a star-scale structure cannot rely on localized physical conduits or centralized pumping stations, which present single points of failure and severe flow bottlenecks. The Hobart architecture resolves this by configuring the interior gaps of nested units into a continuous macrovascular capillary network. By programmatically withholding electrostatic bonds along pre-calculated internal paths, the structure creates massive, open arterial tunnels through its core. High-velocity ionized plasma, raw gaseous matter, and thermal electrolytes flow through these primary channels, connecting opposite poles and faces across millions of miles. 5. Microcapillary fluid and power exchange. Branching off the primary arterial channels are microscopic inter-unit capillary pathways formed by the adjacent pentagonal faces of individual blocks. Every 1-mile unit interacts with its 12 immediate neighbors through near-field electrostatic and magnetic exchange matrices. Energy, raw nucleons, and conductive fluids bleed through these facial interfaces, allowing matter and electricity to circulate deep into the dense structural walls. This fluidic exchange system ensures that every individual unit receives continuous thermal cooling and power replenishment directly from the internal arterial stream, preventing localized energy starvation or heat buildup. 6. Bidirectional polar equatorial fluid topologies. The internal vascular network is dynamically reconfigurable. Based on environmental stresses or operational shifts, the units adjust their internal field alignments to redirect fluid flow along optimal vectors. During high-output energy harvesting phases, cold space electrolyte fluids are siphoned inward through polar openings, routed directly through the core of the mega unit to absorb internal thermal loads, and propelled outward along equatorial paths. This bidirectional circulation mimics a high-pressure cardiovascular system, ensuring complete metabolic balance across three-dimensional space. 7. Dodecahelix bone rings and skeletal mechanics. The primary load-bearing framework of the organism consists of mega units arranged into dense, structural dodecahelix bone rings. These rings form the skeletal foundation that anchors the outer harvesting arrays and generator tracks against gravitational collapse. Rather than forming rigid, unyielding circles, the units within these rings are braided into hollow, multi-stranded helical ropes. Because the units are bound by dynamic electrostatic fields rather than rigid mechanical fasteners, any localized gravitational shear or kinetic shock is absorbed and dissipated as harmless rotational torque along the spiral strands. 8. Gravitational orientation and the three-phase fall alignment. When a dodecahelix bone ring is deployed within a deep gravitational well, such as the perimeter of a star or black hole, the mega units execute a specific structural orientation known as the three-phase fall alignment. The units orient themselves so that three interlocking pentagonal faces directly confront the inward gravitational vector. This nonlinear tripod configuration divides the inward collapsing force across multiple structural axes, translating direct gravitational compression into lateral field tension and preventing localized material buckling. 9. Elastic structural curvature and tension balancing. Because every individual unit is held in place by programmable static electromagnetism, the skeletal bone rings possess absolute elastic flexibility. Under extreme kinetic impacts or changing orbital dynamics, the geometry of the ring naturally stretches, curves, and expands. The electrostatic locks between the 1-mile units allow the modules to slide past one another along controlled magnetic tracks. The ring lengthens along high-tension vectors and condenses along high-pressure vectors, meeting seamlessly at the rear to maintain an unbroken, closed-loop skeletal foundation. 10. Specialized mega-unit classifications. While every baseline 1-mile unit is identical in its underlying capability, their aggregation into star-scale mega-units allows for specialized functional differentiation. The macroorganism organizes its nested units into distinct structural organs, structural bone units, dense, hollow lattices optimized for high tensile load distribution and arterial fluid routing. Swarm proliferation units, hyperdense storage chambers designed to hold compressed, standby modules for rapid deployment. Digestion units, high-energy processing maws equipped with electrostatic cutting matrices for refining raw material. Radiation steering arrays, massive, coordinated fields of deployable mirror sheets used for solar energy management. 11. The hollow crystalline bone architecture. To maximize structural efficiency while maintaining fluid circulation, the primary skeletal elements are constructed as hollow dodeca crystalline mega units. These structures utilize a multi-layered fractal lattice that leaves 60% of their internal volume as open space. This hollow design drastically reduces the overall mass of the skeletal rings, minimizing their own gravitational attraction, while providing massive internal conduits for fluidic cooling and energy transmission. 12. The digestion mega unit and material refinement. To sustain continuous growth without relying on external supply chains, the organism utilizes specialized digestion mega units. When the structure encounters raw celestial matter, such as asteroids, moons, or gas clouds, these units deploy wide electrostatic cutting lattices. The incoming material is drawn into the hollow interior of the mega unit, where high-voltage magnetic fields and mechanical crushing forces reduce solid matter into a uniform stream of ionized plasma and unrefined nucleons, which are immediately channeled into the capillary network. 13. The swarm proliferation matrix and one-in-the-chamber reserves. Systemic survival requires immediate adaptability to structural damage or sudden expansion demands. The swarm proliferation mega unit functions as an automated manufacturing womb. Housed within its hollow interior cavities are millions of fully assembled, pre-programmed, 1-mile units sitting in a low-power standby state. This one-in-the-chamber reserve protocol allows the organism to instantaneously eject thousands of fully operational units into a compromised vector to repair structural breaches or expand local operational arrays without delay. 14. Decentralized kinematic mirror reflexes. A fundamental innovation of the Hobart architecture is the total elimination of centralized control networks and processing latency. A star-scale organism spanning millions of miles cannot wait for a central processing core to send command signals across light seconds of distance. Instead, the system relies on decentralized kinematic mirror reflexes. Every individual unit operates under an identical, immutable mathematical rule set. When an individual unit senses a local physical stress or initiates a structural shift, neighboring units do not analyze the event through software. They instantly calculate the exact mechanical action required of themselves to maintain geometric balance and mirror the movement natively. 15. Action-reaction physical coordination. The kinematic mirror reflex functions as an instantaneous physical wave across the macrostructure. If a localized impact pushes against one side of a dodecahelix bone ring, the affected units adjust their internal flywheel speeds and fusion jet vectors. The adjacent units perceive the shift in electrostatic tension and immediately adjust their own positions to support the load. The movement propagates through the structure at the speed of field interaction, allowing a megastructure spanning astronomical units to react to environmental hazards with the fluid grace of a single biological muscle. 16. Field-based modular assembly and disassembly. Because all structural bonds are maintained via near-field static electromagnetism, the Hobart architecture completely rejects permanent welds, rivets, or physical latches. At any point during operation, any mega-unit or individual 1-mile module can instantly disengage its electrostatic locks and transition from a rigid solid state into a fluid, mobile swarm. Once the necessity for a specific structure ceases, the modules decouple and flow smoothly to new coordinates to be reassembled into different functional organs. 17. The mechanics of instantaneous morphological shift. The transition from solid infrastructure to fluid mobility is governed by localized field modulation. When a structural shift is triggered, the units drop their near-field electrostatic attraction while maintaining long-range magnetic tracking alignment. The structure opens up, allowing units to glide past one another on frictionless field cushions. This capability allows a massive, rigid Dyson-style harvesting array to flatten into a long-range transit line or condense into a dense protective shield within minutes. 18. Solar energy management via retractable mirror arrays. Energy harvesting and thermal protection are actively regulated by the deployable solar mirror sheets embedded in every 1-mile unit. When deployed, these high reflectivity sails extend outward from the dodecahedral faces, combining with neighboring sheets to form square-kilometer mirror arrays. These arrays can be angled to focus raw stellar radiation directly into the digestion maws for material refining, or turned outward to reflect dangerous stellar flares away from delicate processing cores, providing complete radiative control. 19. Kinetic stabilization via internal flywheel matrices. To prevent unwanted rotational drift and maintain structural orientation across light years of space, each unit utilizes its internal high-mass flywheel. When external forces, such as solar winds, gravitational tides, or fusion propulsion thrust, exert unwanted torque on a skeletal ring, the internal flywheels across millions of units execute synchronized rotational acceleration. This collective angular momentum cancels out external torque, holding the macroorganism in a rock-solid, zero-vibration spatial orientation. 20. Active propulsion via perimeter fusion jets. Locomotion and spatial repositioning are driven by the omnidirectional fusion jets installed along the edges of every individual unit. By channeling a small fraction of the internal plasma stream to these perimeter thrusters, the units generate coordinated vector thrust. When millions of units fire their jets in synchronized patterns, the macroorganism can alter its orbital trajectory, navigate complex multi-star environments, or execute slow, deliberate turning maneuvers without placing mechanical strain on its internal skeleton. 21. Prevention of macro-scale gravitational implosion. A major failure mode of star-sized megastructures is gravitational implosion caused by the collective mass of the structure itself. The Hobart architecture prevents this through a combination of its hollow crystalline bone geometry, fluidic mass redistribution, and active thruster balance. If a sector of the organism becomes dangerously dense, the capillary network pumps fluid mass away from the region, while the perimeter fusion jets apply outward counter-thrust, holding the structural frame outside its critical gravitational collapse threshold. 22. Mitigation of thermal overload and heat death. Energy generation on a Kardashev Type 2 to 5 scale creates monumental waste heat that can melt physical components if trapped. The Hobart architecture manages thermal energy through continuous transpiration sweating and radiative mirror dispersion. Superheated fluids flowing through the capillary channels are directed to the outer skin of the units, where the heat is radiated directly into the absolute zero of space. The cooled fluid is then re-siphoned back into the internal arterial channels, completing an immortal, closed-loop cooling cycle. 23. Absolute resource self-sufficiency and metabolic balance. By combining high-density energy storage, continuous material digestion, automated unit replication, and closed-loop fluid recycling, the nested stellar unit architecture creates a completely self-sufficient metabolism. The organism never starves because its digestion units continuously process ambient space debris and stellar mass. It never overwhelms itself because its replication loops are strictly throttled by real-time structural needs. It never collapses because its kinematic reflexes and dynamic field bonds absorb all mechanical stress. 24. Integration across Kardashev Type 2 to 5 scales. The versatility of the nested 1-mile unit framework allows civilizational infrastructure to scale seamlessly across evolutionary tiers. Type 2. Individual stellar harvesting rings, Dyson flower swarms, and planetary digestion arrays around single stars. Type 3. Multi-star orbital webs, galactic arm logistics networks, and central black hole encapsulation complexes. Type 4 and 5. Intergalactic propulsion corridors, multi-singularity flywheel cores, and universe-spanning macro-quantum metabolic lattices. 25. Conclusion. The immortal macroorganism. The Hobart nested stellar unit architecture represents the complete integration of mechanical engineering, fluid dynamics, and biological self-regulation at the cosmic scale. By standardizing the 1-mile universal dodecahedral unit as a flexible, power-dense cellular block, the architecture eliminates the traditional boundaries between machine, structure, and organism. Through its macrovascular capillary geometry, elastic dodeca-helix bone rings, and latency-free kinematic reflexes, the system achieves permanent structural order. It transforms civilizational infrastructure into an immortal, self-repairing, and infinitely adaptable cosmic titan, capable of surviving and thriving across the deep lifetimes of the universe.